All right, we're going on now to topic 2.4. And again, using the additional exercises that are found in the booklet we have for Math Zone. This topic deals with what is called inequalities. Now, an inequality uses one of these four signs here. This will be 1, 2, 3, 4. This sign is read greater than or equal to, less than or equal to. And then it's given in set builder notation. This is our first example. Now, they're related to equations, but we have an inequality sign in the expression here. So this is read, x is such that x is greater or equal to -8. And then what they want you to do is to graph this equation or inequality. So usually they'll give you a number line. And what I suggest to keep it simple is to put the item you're interested in on that number line. You don't have to write all of the characters there. There's, I'm interested in the -8. And then I look at it and say, x is greater or equal to -8. So -8 is in the set. And in high school, what we used to do is put like a little dot there. And then to indicate that it's also other values greater than that, we would darken this line, make this arrow bigger, and that would indicate the graph of this set builder notation. And we also have another notation we'd like to introduce. It's called interval notation. Now, interval notation doesn't use the solid dot. So what they're going to use is a bracket to indicate that the -8 is a member of that set. So interval notation would be, it starts using that bracket at -8, and it goes to positive infinity. All right, in example 2, little modification. Again, it's set builder notation, but it's saying that x is such that 3 is less than x. Now, what you could do if you want to say, can you write it a different way? And the answer is yes. You could put the x first. Now notice the open end is toward the x, and then the 3 would go like so. So this is legal to do, to rewrite it. Means the same thing. So what we have here now, the number we're interested in on our graph is a 3. But here it says x is greater than 3. So 3 is not included in the set. So in high school, we used to put a circle around it to indicate it's not included in the set. And again, thicken the line and the arrow indicating it goes on. But in Math Lab, the way we're doing it here, instead of the hollow dot, we're using a parenthesis. So in interval notation then, there would be a parenthesis indicating that 3 is not a member of the set. It starts after it, and it goes to positive infinity. And our infinities always have a parenthesis. So this is basically what we have for the first two, and we'll review this as we do some others. Okay, these are some others. Notice it's set up a little differently. This is called a compound inequality. It's read, x is such that -1 is less than or equal to x is less than 4. So the two numbers we're interested in is a -1 and a 4. And the sign that we have is that x, -1 is less than or equal to x. So x is greater. So here we would put like a solid dot, but we're going to use our bracket. And then here we're going to use our parenthesis. And the area that we thicken in is right there in the middle. So this is where our x values are. A -1 is included in the set, and a 4 is not included in the set. So for interval notation, this would be just like this, -1, comma, 4, parenthesis. I always suggest to my students to graph it, and then right from the graph you could write interval notation. And for this one, again, this is the solution. We're just showing you how to graph. X values in the center. We have here a -4, there a -1. And again, our signs do not include the equal sign. So when it's just an inequality, these two top ones, these are going to be parentheses, and these will be brackets. And I guess I have them switched around, but you get the idea, hopefully. And so this one will be a parenthesis going this way, a parenthesis going this way, and then this filled in the center. So our interval notation will be -4, comma, -1, and that's what it'll look like. Okay, so our next few examples are now actual inequalities where we have to solve for our letter x. And here we're using pretty much the same technique that we use for solving equations. And I particularly like to use this idea of transposing, getting a number from one side of the equation to the other side just by changing its sign. That's a shortcut. So here we're going to take a -4, bring it to this side, it becomes a +4. -7, +4 gives me a -3. So just transposing this. And then now graphing it. The number we're interested in is a -3. And notice it's greater than or equal to, so we're going to use a bracket and thicken the line. And interval notation is like so. All right, this one again, we're going to transpose. This side just becomes an x. -2x, -2x, x, -6. And this is x is less than. So we're going to have the parenthesis go this way, lines thicken, arrows thicken. Interval notation is a new one. It's coming from -infinity up to a -6 and a parenthesis. Again, these inequality signs use parentheses, these use brackets. And again, I have them switched around, so you have to, depending upon which you have. So if it's greater than, we'd use this one. Less than uses this one. And the same thing. Greater than is this one. Less than uses this one. Okay, here again, transposition is going to be very useful. You have a variable, a number, variable, a number. So we're actually at transposing stage. Transpose this becomes a negative 8x. So this just becomes an x. This is a negative 5 on this side. This is going to become a positive 5. So these are sort of easy to solve. And our number is 8. And it's less than or equal to. So it'll be a bracket facing this way. And interval notation, negative infinity, 8, bracket. And for any of these, if you have any questions about them, bring them into Math Zone, and we'll go over them with you and review anything we have here. And again, dealing with fractions, if there's only a single fraction like this, the technique we're going to use is to use the reciprocal of this number, so we get an x. So that will be 5 halves. 5 halves. So the 5's cancel out, the 2's cancel out, we're left with an x is greater than, cancels, 10. So our number we're interested in is 10. 10 is greater, so we're going to use a parenthesis and like so. An interval notation. In number 11, I'm skipping a few. Again, in math, on the integrity, we have them all listed. We're going to take this and transpose it to the other side. And it becomes a negative 7 here. So this is negative 16. Transpose this, sign changes, add them together. And now we have a negative 4x. And this is a very, very important note, that when we go to isolate the x and divide by a negative 4, in order to keep this statement true, we have to reverse the direction of our inequality sign. Here it's less than. It will now become greater than. And I'll show you why that's true. There's my x, and this will be 4. Now, why is that true? Let me go over here. We all know that 4 is greater than 2. That's a true statement. If I multiply this by a 2 and this by a 2, I now get 8 is greater than 4. That is still a true statement. But how about if the 2 was a negative? This would be a negative 8, and this would be a negative 4. Is a negative 8 greater than a negative 4? And the answer is no. So in order to keep this statement true, if we're multiplying or dividing by a negative, which is what we're doing here, we have to reverse this sign. Now it's true. So that's why I had to reverse that sign in order to get and keep a true statement. So when we plot this, this is going to be a 4. And now this is critical. X is greater, so our parenthesis goes this way, like so. Interval notation, 4 comma, positive infinity. So I would say, mentally, put a star by this, because this whole item right here is super important. Okay, now what we're going to do is something a little more complicated. So as you look at solving equations, very similar to solving inequalities, we have one in which there are fractions. So what are we going to do first? We'll get rid of all our fractions by multiplying every term by our common denominator. We have a 3, a 5, a 10, and a 5. So our common denominator, see if you could figure it out. A 30. So you do it like so. I'll put it in red. So what we do is we're going to now multiply each term by 30. But before we do that, we cancel out. And again, what we want to do is get all of our denominators to be 1. That is, get rid of the fractions. So now we have 2 times 10, which will be 20, minus, there's our minus, this is going to be a negative 24x, is greater than or equal to, 3 times 3 is 9x, and then this is going to be a 6. And it never hurts to check your work. A good technique. So in black was our original equation. We had these as denominators. We're looking for a common denominator. We said it was 30. So we're going to divide or multiply through, but 3 goes into 30 10 times. So 10 times 2 is 20. 5 goes into 36 times. Keep in mind there's a negative there. Negative 6 times 4, negative 24x. This doesn't change. 10 goes into 33 times. 3 times 3x, 9x. Once, 6 times 1 is 6. Now what we want to do, another hint, is to try to keep your variable positive. If that's positive, you don't have to reflip that sign at all. So we're going to bring this negative 24 over to this side, and that's going to give us a 33x. I'm going to bring this 6 over to this side. It's going to become a negative 6. So this becomes a 14. And then I'm going to divide both sides by a positive 33. And that's what x will be. X is going to be, and I could write it this way, less than, again, x is less than or equal to 14 33s.